Hey, good morning everyone and welcome to our channel Learn Data Science with Pranjal. So in this video we will discuss the concept of our lag and what concept of autocorrelation. So autocorrelation as in your ACF and PACF, autocorrelation function and partial autocorrelation function. So this video is in continuation of the previous video wherein we have discussed the values of P and Q. So how many past actual terms and how many past error terms. So what does P means and what does Q means in our AR model and MA model. So any model which we are building, obviously we need to have the knowledge of what is the value of P and what is the value of Q. So many people while building the model that use AutoRegressive function, and AutoRegressive gives me the value of P and Q, and they use that value of P and Q and they do the forecasting. But rarely people understand how are the values of P and Q are calculated and what is the concept of lag, because lag is basically used in calculating your P and Q. So let's get started. How to find the values of P and Q. So basically, values of P and Q, that is how many past actual terms and how many past error terms, are calculated using my ACF and PACF, autocorrelation function and partial autocorrelation function. And ACF and PACF is calculated using the concept of lag, LAG. So lag, as the word indicates, that there is some lag or there is some time gap. So basically, whenever an event occurs, the result or the consequences are seen after some period of a time. So let's say if it rains today, it might take few hours before you start seeing the water is getting filled up in the dam. You are studying today, and based upon your studies, you may see the result. You may get a job or desired result after, let's say, a few months. A government may take some decision, some policy action, and the results which you may see maybe after a few months or few quarters. You appoint a new CEO, and new CEO may take some actions or make some policy decisions, and the results are seen after a lag of some quarters or some months or probably 1 year or two. So that is what the concept of lag is. And the same concept we will use to find the value of P and Q. So to understand the concept of correlation and partial autocorrelation, let me talk about the linear regression. In linear regression, we have an equation of y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Right. So when I say y is equal to beta naught plus beta 1 x1, so it means I was saying that y is dependent upon my x, and y is dependent upon my x2, y is dependent upon my x3. Same thing we are going to use in our lag. So what I've done is I have created one sheet. So let's say xt is the actual time series. Now time series with your lag one. Time series with your lag one would be something like this. Okay, I'll put something like this and I'll put like this. Okay, so consider this was your day one, this was your day one, day two. Let's say my data was the sales on the daily basis. So day one, day two, day three, day four. So in lag one, what I have done is I have written the day two number in front of day one, day three number in front of day three. And if I want to find the lag two, then what I'll do is I'll take this thing and I'll put it like this. Okay. So what I've done is basically in front of this thing, let me rearrange. In front of D3, I have put in D1. So suppose if I take these two things and if I find the correlation, so let me highlight one number. So if I have to make a statement on these two numbers, then I'll say if the sales was 112 on day one, then the sales is 118 on day two. If sales was 118 on day two, then sales was 132 on D3. So if I find the correlation between my original, time series and the lag one. Let's say something like this. Okay, so probably. So this is my correlation values. Now observe the cell where in this thing. So when the cell is empty, the value is 0.622. And when I put 0 over here, I get 0.49. So one represents your correlation and the another represents your partial correlation. Now similarly, so let me say this was for my lag 1. Similarly, let me find between my original and the lag 2. So if I say original and the lag 2, what I'll do is I'll select the original and I select this thing. So if you notice, correlation between my original time series and the lag 2 is almost 0, 0.47, 0.47, or you may want, you can put 0 over 0.47 and one of them is your 0.32. Suppose if I remove this thing and if I remove this and this. So correlation between my original and the lag 1 was 0.62. Original and the lag 2 is 0.47, which means if I have to do the forecast of for my next day, which means if I have to do the forecast for my Wednesday, I only need to look up the data of Tuesday and no need to look up the data for Monday or t minus 2. I don't need to look up because correlation itself is almost 0. If there is no correlation with the t plus t minus 2 day, then why do I even need to look into that data? So it means if I have to predict the values for the next day, only just previous day is enough for me in this time series. And this concept we use to find the values of P and Q. Now let's quickly see the graphs of ACF and PACF. And let's see how to derive the meaning from ACF and PACF. So I've written two sentences on ACF. So ACF stands for autocorrelation, correlation of series with its own lag. PACF, partial autocorrelation, after removing the controlling effect of time lags. So basically you can put zeros over there. So ACF and PACF combination is used to find the order of AR and MA. Okay, so these graphs we will see in our next videos when we do the coding. So there is an inbuilt function which will automatically give you this graph. But let's say if you get this graph, then how to find the values of P and Q? So the first graph, the first graph is of your ACF and the second one is of your PACF. So basically what you can do is you can find the correlation. You can find the correlation between your lag. You can find the correlation of your original series and the lag 1, original series and the lag 2, original series and the lag 3, and this journey continues till your lag n. And we already know that correlation is always between my 0 to 1. So let's say if this is 0, this is plus 1 and this is minus 1. So let's say correlation between my original and the lag 1 was this. Original and the lag 2 was this, and then over here. So if you notice after your lag 1, lag 2, after your lag 2, correlation has suddenly gone down or it has decreased sharply, which in this case, this graph is meaningful or useful to me. But if the correlation decreases very slowly, so let's say if correlation is decreasing very slowly, so it is something like this, then we cannot say that where should we stop? Should I go till only till your previous time? Should I go only till my 3 lakhs, 4 lakhs, 5 lakhs, 10 lakhs? It's very difficult for us to conclude. So if values are decreasing slowly or gradually, that graph is meaningless for us. So in this diagram, this graph doesn't gives me any value, but this graph gives me value. So in PACF graph, if you notice after my lag 1 and lag 2, the values have almost gone down to 0. So it means I can get the value of P. So from PACF, I can get the value of P. And from PACF, I get the value of P. And after my second lag, it has gone down to 0. So it means it is AR2 process. Let's take the opposite graph. Over here, this graph is meaningless for us because values are decreasing slowly. If the values are decreasing gradually, then you don't get a deciding point or the deciding boundary that where exactly should I stop. But in this graph, ACF is a meaningful graph because after my first lag and second lag, if you notice, the correlation has almost gone down to 0. So if ACF, there is a sudden decline in ACF, we get MA. And after your second lag, the values have gone down to 0. So the value becomes 2. So MA2, it means the value of Q becomes 0. So that is what the concept of your lag, ACF and PACF is. So in our next video, we will do a coding and we'll see how to plot this ACF and PACF. They are automatic functions are there, inbuilt functions are there in Python, which will give you the ACF and PACF value. So that's it. That's it in this video. Hope to see you soon in my next video.